The rest of it is straight out of 18 and 10, 18, 11, and 12.
What would you recommend for the high voltage module if somebody were to buy one?
Well, the simplest and easiest way out would be like the neon tube transformers. They come in both alternating current and direct current, and they give out alternating current, of course, and that alternating current can drive your L1 coil.
Okay, great.
Okay, this is one of many devices which I built. I would say one of several hundred, and this is one of the sort of intermediate ones.
Okay.
And technology present here is largely 1800s.
And what is this here?
What is the device?
Yeah, what do you got here?
It's a resonant electrical energy generator.
What does it do?
What I do, I take a low voltage at 12 volts at about 7.5 hours from a battery, and I run it through the device. The first thing I do, in order, the high voltage has to run off 120 volts. So since I'm intending to use a 12-volt battery, I have to bring the voltage up so that the high voltage module can run.
Okay.
So this is an inverter here.
Okay. This is just a Radio Shack part.
Yeah, it's everything you see here except these. Most anyone could get, and these. Now this and this, unless you get them from me, you don't get them.
So these are your homemade ones here.
Well, they were special made for me.
What are they? Can you give me an
Well, these are 10,000 volt capacitors.
idea? Wow. And what's the
This is a 9,000 volt high voltage module that is similar to the little one that I showed you, and this is from the same people. This is about 6,000 volts, and this is 9,000 volts.
Okay.
This is essentially a solid state device, and so is this.
Okay. So how does it go here?
Where does what go?
Where does it start?
Okay, it comes in here,
Okay.
and comes from a 9-volt battery. There's a cord that's calculated to a certain length because it's a frequency that works with it's a quarter wavelength of this coil here. The physical length of the input from the 12-volt battery. And the reason for that is that it will recharge the battery if it can communicate with the radio frequency magnetic field that's in the area.
I see. So it's just constantly recharging.
Yeah, the magnetic field from what's going on here will recharge the battery faster than it's being discharged.
That's great. Besides that, being
How do I know that? If you take a light emitting diode, electricity can only flow in one direction in a light emitting diode. Take two of them and reverse them and make a pigtail and put them in the line that comes from the battery to the device. And depending on which one's lighting up, you know which way the electricity is flowing.
Okay.
When they're both lit up, you're taking out and you're putting in at the same time. And the reality is that they're different frequencies.
Okay.
And there's a phone company over at College Station that uses this method of putting different signals on the line and running them in opposite directions at different frequencies. And they have captured the entire radio telephone market over in Europe, and it's being done out of Texas A&M.
Really?
Yeah, one of the professors over there came up with the idea. They laughed at him and made fun of him, and he went ahead and did it. And instead of putting it in service here in the United States, he went to Europe. My son happens to work for him.
Oh, is that right?
Yeah, and what my son does, he's in charge of the computers, and they have an enormous amount of computers in this phone system in Europe, and they're all the time breaking down and having trouble with them. And you can sit here in this office where I am, and I can repair the computers over in Belgium or England or Germany.
No kidding.
You can diagnose them and repair them from a remote computer.
That's right.
And,
That's what your son does.
yeah,
Wow.
he's in charge of that department for the phone company.
That's pretty impressive. Well, show me more here. What else have you got?
Okay, we've got 12 volts coming in. We have a kickback diode here, which prevents a kickback from the inverter to the battery.
Okay.
And we also have on the input where the 12 volt comes in, we have this pigtail set of light emitting diodes, which tell you that you're charging your battery at the same time that you're using it.
Okay.
And once we get past that point and get into this inverter, this is 9,000 volt high voltage module, which would be, it's a version of the Tesla coil, except it's a solid state version.
Okay. Okay. That makes sense.
It does the same thing as a Tesla coil, except a solid state version of the same action.
Yeah.
So anyhow, in order to control that, since we don't want to use the full 9,000 volts, I have a neon tube transformer control here, which controls the amount of the 110 volts that comes out of this into this. I can use the whole 9,000 volts, or I can use any part of it. And the reason I have to cut it back is because what's over here cannot take what's over here. Well, I'm going to end up with a lot more voltage than I can manage. So I have to reduce it. It's easier to reduce it on the low end. Once it gets to the high end, you have trouble, special equipment, and a lot of trouble varying it. So I vary it on the input on the low side.
Yeah.
Okay, I get to the high voltage module, and on neon tube transformers, they have two output wires. So I have to take the electricity that's on the two output wires and put it back together as one source of electricity. And then I have to pump it through the L1 coil and then back into the system. And then I have the capacitor bank here in order to help regulate that.
And that's, I'm sorry, you said that was 100,000?
Well, these are 10,000,
Okay.
or maybe 15. I don't recall just a moment, but they're more likely 15.
Okay.
But they were done special order by Cornell Dubier for me, and they were free.
Well, that's nice.
Because most of the companies like that have a department where they will make up samples for you if you're doing research and development, and you need something which they don't have in the catalog, and they will make them up special for you, and that's exactly what happened here.
Really? That's
Yeah,
great.
I called them and I asked for something, they didn't have it, and they told me, asked what I wanted it for, and I told them, and they said, well, we'll make you up a couple of dozen for samples and send them to you. The regular price on these will be $300 each, but we'll make you some samples.
That's great. Well, congratulations.
So that's how I got those. One day a box arrived and they were there.
That's really
It was about 6 months later after I'd forgotten about it.
So what happens next?
Okay, once we get to the, this is the broadcast end of it, or the part that sets the electromagnetic field into oscillation.
Now, how do you do that? Is it sending a radio wave through?
Well, it's when you pulse something and you pulse it through a coil like this, a magnetic field builds and collapses.
And that's all you
It's a collapsing, building and collapsing off and on that spins the electrons. The magnetic field, and then the magnetic field off, and they'll spin back to where they were. So you've got the coin flipping with the electromagnetic component flipping. And once you've got it flipping, then you're in business.
So that's the whole trick to this. Is just
Yeah,
get it-
yeah. Once you got it flipping, then you've got to have something to collect it with, and then the rest of this is the collector and storage part.
So what do you have? Just a couple of capacitors there? And
No, those are actually there's 8,000 volts worth of capacitors there.
are those special made?
No,
Really? What's the little tube on the end there?
which one?
It's a little yellow.
The yellow one? Okay, that has a double meaning. In this case, it has no meaning because I'm already charging the battery from over here.
Oh, was that used to?
But
supply energy?
but the energy coming from here before it goes out to the transformer is passing through this one, and that's building a magnetic field. This one is not connected to this one in any way except through a magnetic field. So this becomes a generator of electricity, and you can charge batteries from that.
That's great. I mean, that's a great system. How much energy would you say this little system could produce?
This one, what's the output on it?
Yeah.
It's about 16 kVA,
Great.
which is a lot of energy.
Yeah. And that's
It could go higher than that. That's with this thing turned down on low.
wow. Now does it like run itself out? I mean,
No, there's nothing here to wear out.
Wow. So there's no.
The capacitors are self-healing.
So this is it. You've got a closed loop system that charges itself and kicks off enough energy to.
Once it's going, it's on its own.
Is it? Do you ever lose the effect by shutting it off?
You have to start it again.
I mean, have you ever had a problem where after shutting it off, you turn it back on?
No,
and the effect-
no,
So it's not a one-shot deal where you.
no, no. There's nothing here that will degrade.
Great. Did this evolve into anything else? Is this
Yes, no. This led into quite a few things.
like I mean, is this your final model for this?
No.
Okay.
No, this is sort of an intermediate model.
Yeah.
And there's a larger one sitting over here, a more commercial type. This one actually, the one in the suitcase calculates out at about. I put in the book a little article I gave you. I think it was 27 kVA.
No kidding.
It's a one. It's about half the size of this. So this is capable of probably around 50 kVA.
Now, is this something that you give away as far as selling plans to people, showing people? How to
Well, the plans for some of these things are in the publications.
so this is not any great secret. This is out there.
No, it's looking people in the face.
So you should see these like on cars next week if people just pay attention.
Yeah, well, if they know what they're looking at, they have no problem with it.
So you've already done it. So the only barrier to people actually using this is just simply overcoming their own willingness.
It's more of a psychological thing.
Well, this is
Commercial model, and the absolute output level on it, I don't know, but some of the components in there would probably limit it to about 35,000 volts at probably about 200 amperes, and that is an enormous amount of electricity. So you can see that it has the same components that the other device has. They're just scaled up somewhat.
Have you used this one here?
I've had it. I started it, and I know that I've tested it. But I haven't ran this particular one for any extended period of time, except to just start it.
So this was just sort of an experiment to see if you could build.
Well, basically, it was just to see how the components fit on the board. Was what it was. Because I did the schematics and passed them on to other people, and they're building them.
Okay.
Breaking into the circuit and limiting the electricity so that the device can function at its normal level. There's something that's called a varactor that you find, like on your computer, you have a thing that keeps the specs out, and if the energy exceeds the level which is appropriate for the computer, it'll go back into the earth ground. Okay, these devices have that on them, and they will function at the level of whatever machinery that you're wanting to run will manage. So otherwise, in almost all cases, you'll be burning up the devices that you're working with. We're going to see in a little bit when we turn these lights on over here that they're disintegrating in front of your eyes. And you'll see that the energy level is probably greater than what the bulbs were supposed to be having.
What are we looking at here?
We're going to be looking at a small briefcase model, which is about 1/2 to 1/3 size of the one that's on the top shelf over here.
Okay.
And it's all inside the top half of that suitcase there, and it's so small and insignificant looking that it would be embarrassing to me for you to see it. And that's part of why I don't want you to see it.
Oh yeah.
But
What do you plug in there?
we have a electrical drill there. That's a 1/2 horsepower drill, I believe.
Okay.
So this will demonstrate useful energy. This can run a lot larger things than what we're seeing here. As long as it's tight to your fingers, it will be okay. But we're going to demonstrate useful energy, and we're going to use a small suitcase that has wheels on it and a puller handle that I take with me sometimes to conventions. It should be all right, and a portable device which produces enough electricity that you can power the whole neighborhood. During an ice storm about a year ago, the entire neighborhood, maybe almost 250,000 houses in the area were without electricity, and I took the plug, the double-headed plug there, and reversed it and pushed it into the wall plug in the house, and we had lights when no one else had them, and it caused quite a stir. The neighbors know what I'm up to, and they were really paying attention.
Okay, what are you going to show us here?
We have the portable device which I carry with me sometimes to exhibitions, and we're going to demonstrate that it produces useful energy. We have previously, it has a ground wire on it which is separate there, which may cause confusion to some people, but we all touched the ground wire and verified that there's no electricity coming through it. So it's there as a safety device, and if the device starts producing more energy than it's supposed to be, the excess energy will go to the earth ground. And that's the reason for it. Now we have a wall plug on the side of it, which is conventional. It's exactly like the ones in your house. And we can plug any device which you have, which will fit that kind of plug into it, and it will work. The electrical power drill is 1/2 horsepower, which means that it will be putting out something like 300-400 watts. That should indicate useful energy. And we're going to switch over to the electric light bulbs, and I'm going to move this thing so you can see them better. The coil that's sitting beside it is my first coil, first one I ever built. And I don't think I will build another one like it because that heavy copper there is used for grounding at your electric meter at your house. And I took it and I wound the coil, and then I took the plastic poles there and drilled holes in them, and then wound the coil through those plastic holes. And it took me quite a long time, and it was not very, the heavy copper did not want to do what I wanted it to do. But you can see that it turned out all right. It runs at 17 megahertz, that particular coil.
Okay, all right.
Okay. Okay, this is our light bulbs which illustrate useful energy. And you will notice that the filaments in there are obvious, and they're coming apart on you while you're watching.
many watts are the lights?
That's 400. Let's see. Wait a second. They're 120 volts at they're 100 watts. I believe 150 maybe. I'm not sure. I have all kinds of bulbs. I move them in and out, but they're like the ones that are above you here to a certain extent. And it's acting up a little bit now, but you'll see it's coming back.
Now, why does
And
it
it's
look
probably going to burn those bulbs out very shortly.
like,
You better unplug it or we're going to lose the bulbs.
now, I noticed at the Tesla conference that it pulsed like that, it dimmed down and it brightened down.
Yeah, see, it's beginning to run away with itself a little bit. That's a technical problem, which in that particular device hasn't been solved, but other devices it has been. But you could see that when it was blinking, each time it came back at a higher level.
Yeah.
It would keep doing that until those bulbs turned into flash bulbs.
Wow, that's great.
And I've had it do it to me, so I'm aware that it will do that. The bulbs like that are about $1.50 a piece, I think, or something. So I've tried to keep them for a while.
Come on. Do it. 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 Who's doing it? Do it. Do it. All of it. Do it. Come on. Do it now. Now we do the rest.